You've probably looked up at a big, fluffy cumulus cloud and thought, that looks like a marshmallow I could take a nap on. It's the very definition of light, airy, and harmless. But what if I told you that same adorable cloud might weigh over 1,000,000 pounds? Yeah, 1,000,000 with 6 zeros. A single modest cloud can contain up to 1.1 million pounds of water. That's heavier than a Boeing 747 airliner. Here's the massive paradox. How the heck do clouds float if they're basically airborne water tanks? Shouldn't they just fall out of the sky like soggy boulders? This is the ultimate, relatable situation that defies common sense. It's the shocking conflict that instantly hooks us in. We have to know the secret behind this physics-defying trick. The cloud paradox hooks us because it uses the curiosity gap. It presents a familiar object, then introduces a shocking, incomplete piece of information. Our brain instantly asks, how is that possible? I must watch to fill the gap. But there's a second, more viral trigger, the judgment and debate trigger. By focusing on the seemingly impossible conflict, heavy, yet floating, we invite everyone to weigh in. Compare this to a dull title like Cloud Physics 101. Instead, we create a familiar social scenario, just like a story about awkward moments at a party. This taps into the public's desire to judge, empathize, or debate the situation. Everyone gets sucked in, from scientists to casual observers. We're applying a social, viral formula to a science topic. The first secret to resolve the paradox is the difference between mass and density. The total mass is huge, yes, but a cloud is not a giant blob of water. It's made up of countless tiny water droplets, or ice crystals. Each droplet is smaller than the width of a human hair. Crucially, they are spread out over an enormous volume. If you condensed that 1,000,000 pounds into a bathtub, it would instantly sink. But when spread over a cubic kilometer, the density becomes incredibly low. It's only about 0.5 grams per cubic meter. That's why you can walk through fog, which is a cloud on the ground, and feel nothing. Simply put, a cloud is like a 1,000,000-pound secret that's excellent at social distancing. The cloud stays up primarily because of buoyancy. It's the same principle that allows a hot air balloon to rise. Warm, moist air rises from the ground, carrying water vapor with it. As that air rises higher into the cooler atmosphere, the vapor condenses into droplets. But here's the key piece of physics. The cloud is still warmer and less dense than the cooler air above it. Think of it like a bubble rising through liquid. In the atmosphere, warm and light always floats above cold and heavy. The cloud is essentially surfing on an invisible cushion of cooler air. It's a continuous, gentle push from below. This detail makes the complex physics instantly relatable and logical. The next logical question for the audience is, why don't they float forever? Clouds do eventually fall apart or fall down. Over time, those tiny water droplets collide and combine into larger, heavier drops. They become heavy enough to overcome the upward wind currents, holding them up. When that critical weight is reached, boom rain. It's like a very slow motion, high-stakes game of Jenga. Each drop that merges is like another block being added to the unstable stack. Eventually, the enormous mass of water overcomes the buoyant force. Gravity wins the battle. This final defeat against physics gives the content a satisfying emotional arc. What about thunderclouds? They look heavier, and that's because they are. Cumulonimbus clouds can hold even more water and reach up to 60,000 feet high. They look dark because they are so thick they block out the sunlight. These clouds contain nature's version of turbulence on steroids. They produce powerful updrafts that can suspend raindrops and even hail for brief periods. But the same core buoyancy rules apply for them to float. The mention of turbulence is an engagement trigger, shifting to a high-stakes scenario. This begs the practical question, why don't clouds crash into planes? In reality, planes fly through most clouds all the time. Most clouds are not dense enough to interfere with flight. The danger only arises inside those colossal thunderclouds. That's where extreme turbulence, ice, and lightning become serious threats. That's why pilots go to great lengths to avoid flying through them. Advanced radar systems detect these high-density pockets in real time. Pilots use that data to reroute immediately, avoiding the chaos. The physics of floating is usually harmless to air travel, but the violence of storms is not. Now, let's dive into the clouds that fuel the internet's favorite theories. Meet the lenticular clouds, the bizarre, flying saucer-shaped formations. They typically hover near mountain ranges. They form when stable, moist air flows over a range, creating standing waves. Moisture condenses at the wave crest, forming a hovering, lens-shaped cloud. They float with eerie stillness, often freaking people out. Let's be honest, they look exactly like UFOs, triggering a viral visual hook. This demonstrates that physics can create something that looks like pure fantasy. Ever wonder what happens when a cloud just vanishes? That's evaporation in action. If a cloud drifts into drier, warmer air, its droplets evaporate back into vapor. Poof! The water isn't gone. It's just invisible moisture waiting to rise again. But are these clouds getting heavier with climate change? Warmer air holds more moisture, making clouds denser and more prone to extreme rainfall. More evaporation means more water packed into the clouds that do form. Climate models predict fewer clouds overall, but meaner ones. When that water drops, it doesn't float, it floods. The mystery of floating clouds comes down to a delicate balance between heat, density, and gravity. Next time you're watching clouds, remember, you're not looking at fluff. You're looking at millions of pounds of floating water, gently surfing the air. It's one of nature's most impressive magic tricks, all thanks to physics. Now, it's your turn to join the conversation and resolve the paradox in your own mind. What's the weirdest cloud you've ever seen? Drop your best sky watching moment in the comments. Don't forget to like this video. If you were surprised by how heavy clouds are, subscribe to YX for more science that makes your brain float. Hit the bell so you don't miss the next story above your head.